Swayam Prabha. Digital India. Educated India.
So in today's class, we are going to look at elements of mechatronic systems. Okay, why do we understand? Why do we need to understand these elements? Is basically, if you take any system like a CD-ROM drive or your scanner or any mechatronic system, it can be broken into different parts to understand for our kind of consolidated understanding. It can be broken into chiefly 4 parts. Okay, we'll look at these parts in this part of the course, and then we will be in a position to think about many different systems that I was talking about in the last class in terms of these elements. So let's understand what are these elements. Okay, so let's go back to the slides. Okay, now we have seen these different kinds of systems, mechatronic systems. Okay, so maybe scanner, hard drive, these are more kind of a sophisticated systems. Once you understand these, then the simple system understanding may not be too difficult, I would say. So these systems are where a good amount of what you say the knowledge have gone into actually working in practical. Okay, so we'll look at some of these systems in much more detail in the future classes to come, and then we'll talk about as we go along some of the important parts, how this theory, whatever we study in different courses, have gone into actually building these components and what works and what doesn't work, and from the theory to practice. Okay, that kind of a discussions we are going to have as we progress. So let's focus on what are the elements of mechatronic systems. See, as you might have kind of already known or guessed or whatever, the mechatronic systems chiefly consist of these 4 elements. Okay, sensor, actuator, controller, and the mechanical system itself. So now let's kind of understand this with the example of, say, you as a driver driving a car. Okay, so you are sitting in the car at the steering and you are driving a car. What do you do? Can you imagine yourself driving a car? Okay, you have can you think now what are the actuators for your system? You as a driver for the car, as a part of the system, what are the actuators? Okay, so what you are controlling the car with is your hands and legs, and there is an engine to support you in this in terms of some sense of power. But engine doesn't have a smartness to kind of know when to kind of give acceleration to the car, or when not to, or when to stop. That kind of thing we don't have with that smartness is not there with engine. Its smartness is there with you as a driver there. Okay, then sensors are your eyes and ears. Okay, then what do you do? See, suppose you are driving a car and some curve comes. Okay, then you naturally tend to steer the car in the appropriate direction to keep your lane. So you're sensing okay, your position with respect by using the sensors like your eyes, and then you are taking a decision in your head. Okay, that is a controller that is acting in your head, and it gives a command to your actuators, okay, which are hands and legs, to kind of make sure that the curve is negotiated properly. Okay, so this is how things happen when we see ourselves as a part of some mechatronic system. Okay, so the car is really not a great mechatronic system. I mean, in terms, at least the driving part of it. There are many small other subsystems in the modern cars nowadays anyway, but we are not talking about that for now. Like, for now we are just focusing on like some basic car which is having just an engine and like these different steering systems and things like that. And so the plant itself is car with its mass, with your mass also included in that, and some kind of force coming from the tire tractions and things like that. So I'm sure some of you might have worked with the Formula One car, and like you can imagine like if you want to offer now this smartness more and more on the system rather than human, like what are the things that we need to think about. Okay, so see, from this perspective, if you see, I mean, in our life, we are, as a human being, like we are having a lot of this kind of a built-in mechatronic system in ourselves, like in walking or in talking or in whatever you think of, like we are sensing some things, then like processing it in our brain. Our brain acts as a controller, and then we are actuating something. Our hands and legs act as actuators. Okay, so this is very simple way one can kind of like understand what are the different elements of mechatronic system. You just think of yourself as a mechatronic system, and you see that okay, you have different senses. You can sense things, process in the brain some kind of decisions, and then offer those control decisions to the actuators, your muscles and legs, and then they'll start operating. You do that like very often. I mean, you can imagine like if you are playing any game or you are doing any activity, you can think about how you are kind of really taking those decisions. Now the crux of the matter here is that how you can kind of like translate the way you are taking decision to machine. That is where like the whole skill lies. So see, for example, we do it by using like our brain naturally. We don't need to kind of process any mathematical numbers or something. That doesn't happen really when we process anything. See, for example, you are playing badminton, like the speed of shuttle and like position of the shuttle, it's like somehow kind of like correlated in the brain somewhere, and then like you take an action to kind of hit it. Okay, so this whole calculations happen in a fraction of second inside our like brain as a controller. So now our job is to think, see, this is, we anyway do this, so now our job is to think what mathematics can kind of like work the way, same way as our brain is working. Okay, so that is how like we can start thinking, and like you can come up with like different kind of control strategies, analyze them and things like that. So that part we'll do in the future at some point in the course. Okay, so these are the main elements of mechatronic systems, and now we are going to look at more and more details about these elements. Okay, with the examples. So see, first example, like simply a typical robotic system. If you see, the actuators there are motors, or there might be some kind of a gear transmission system along with or there might be some hydraulic actuators for the cylinders, hydraulic cylinders as actuators, or pneumatic actuators and things like that. Then you can have different kinds of sensors for robot. Can you think of what are the sensors? You'll have position sensors. So encoders is a position sensor, or potentiometer will be another position sensor, or you can have tachometers, which are like the speed sensors. Potentiometers, again there can be linear or rotary potentiometers, multiple turn potentiometers possibility. Then you can have force sensors. Typically, like when you want to grip something by the robot, you need force sensors to sense the force of gripping, and like you want to grip it without breaking it, like that. So suppose you want to kind of hold an egg or something, then like this will be very useful. Then you may have accelerometers, you may have gyroscopes and cameras for the vision sensing and things like that. Then controller in the typical robotic system can be analog or digital. Okay, so we'll see what is analog and digital I mean, you know these terminologies, but like when to use what, those kind of aspects we'll have a look at later. Then plant itself is like mechanical construction of robots with the different links and mechanisms. So if you want to analyze robots, that's where like some fundamentals of kinematics and dynamics would be required. And of course, feedback is maybe all the sensors or some of the sensors kind of giving you feedback. Say for example, so some applications may not need a camera as a feedback sensor. Okay, only position sensors are okay to kind of have a feedback from. But camera can be just used as a monitoring vision. Say for example, if you have a drone, okay, in that the camera is usually used for just like taking pictures when the drone kind of like goes from one place to other place, but it is not used as a feedback. Okay, but you can have robotic systems, say assembly systems, where camera is indeed used as a feedback. Okay, so it depends upon what kind of application that you desire to drive by using these robots. Okay, uh, this is one of the industrial example of robot. So many different applications can be done with these. Yeah, you can have spot welding application, or like welding application, or material handling system, assembly system, or some kind of actually doing some metal forming operations and things like that. Okay, so we'll not get into construction of such robots and things like that, but one can kind of see once we have some basic fundamentals of this course in terms of there is design strategies understood. One can look at the construction of such robot, why people have taken such decisions to kind of have certain places only the links, or certain places only the joints and things like that, or placement of actuators at some certain places. So those are kind of the things one can kind of start thinking, and understanding how these fundamentals that we talk about in the course will be actually implemented there. Then you can have this autofocus cameras as another kind of a mechatronic system. Now think of this again, what could be the sensors here. So one can see that okay, there are systems like autofocusing. Okay, so suppose here you have autofocusing. What is the what is the sensor for the system? Okay, so you can have the image taken by the camera on the digital screen. Okay, that itself as a acting as that image itself acting as a feedback for whether it is focused or not, right? You can have some parts of the image which are sharp and blur. You identify the blur part and move the lens, and again see the image getting sharper or not. That is a way one can kind of see whether the image is in focus or not. Okay, so we'll see some sensors are of this kind are there for in especially the modern the digital cameras. They'll have this kind of systems in place. One can see one can think of other system for autofocusing that can sense a range of the object. Okay, so you can shoot a light from, or I mean it's a invisible ray that can go from the camera to kind of some object, and from that object the reflection of this ray comes back. You sense it and you gauge the distance, and once you have the knowledge of the distance, you can adjust the lens according to that. Okay, but that is again somewhat feedback system, but the intent of user may not get captured there. So previously the older cameras will were having that kind of a system in place, but now modern cameras they'll have a actually image sensing kind of a system. And in fact some of these high-ended cameras will also have which part of the image you want to be in more in focus than other kind of choices can be there resting with the user, or they can be set automatically. There are a lot of kind of different options that will be possible in the cameras now. Okay, of course there are older versions of cameras where having a film. I mean, you might not have seen nowadays nobody kind of processes the film for the camera. So this is kind of a somewhat historical kind of a thing. I don't know whether we have some kind of things. Maybe I can try to find out some films if we have. So then the film loading and film advancing, those kind of features were needed. That were automatic in the previous versions of camera. But nowadays, and we all have like these digital image sensors to capture the image, so we don't need that. Okay, this is another kind of a very interesting mechatronic system which is used for like data storage. Okay, so nowadays these CD-ROM drives also are nowadays getting somewhat extinct because we have the pen drives, or like this RAM that is there for the storage device, which is much compact and like much more kind of a reliable way the data can be stored. It is less prone to damage, physical damage at least. There might be electronic damages possibility, but at least physical damage, like you may not have. So this CD-ROM technology is also very, very interesting optomechatronics kind of a technology. We'll go in much more details about this technology, because it opens up a lot of interesting fundamentals to be exercised in many of the designs that you may carry out in the future. So it has like multiple subsystems. Like one of course will be like positioning of the head or the laser which is reading the data from the surface of the CD. Now if you see the distance, if you see here, the distance between the two tracks is 1.6 microns. Okay, you can imagine what is a 1.6 micron. Can you have feel for this number 1.6 micron? If you think as compared to your hair size, okay, your hair size is about 100 microns. Okay, so with respect to that, you can imagine like this is roughly like 2% of your hair size. Okay, so that kind of a small number or small kind of a motion that you want to have. So how do we design system which can kind of like position something which is within the distance of at least like now if this distance is 1.6 micron, our positioning should be at least like 10% of the distance that is given, right? So maybe within like zero point 0.2 microns or 200 nanometers, if you want to have the positioning, how do we do that? Okay, so those are the kind of questions that we need to address while developing the fundamentals of how do we kind of sense this position, how do we actuator, what kind of actuator will be there, how people would take care of friction for such a kind of a positioning. Okay, how friction will not bother such positioning. Those are kind of questions that would be raised, and as we go along, like we'll see some answers to such questions. What kind of technologies people have developed to really drive this very fine kind of a mechatronic system application. Okay. Then there might be some additional kind of systems which is where you just press a button and the CD kind of comes out of your CD-ROM drive. Okay, those kind of systems are also have some kind of a small mechatronics thingy happening there. Okay, so we'll see some of those actually. So we may do this by like actually I'll show you some pictures now to open such a drive and like see what is there inside, and then like look at different parts and see what those parts are for. Okay, if you have at your home or like somewhere accessible some kind of older machines like CD-ROM drive or some floppy drive, or some older computers may some kind of a systems, hard disk systems for which are gone. Okay, don't you open like some new systems. Okay, it's going to be you may not be able to fix it back so that it will still be in working condition. So you typically like tamper with which systems which are like not working. So you may go to shop and repair shop, and they'll have a lot of such systems to give away. So you can take some of them and start opening and checking older mobiles, maybe, for example. So if you do yourself this kind of exploration, that has a lot of value. Okay, so I would suggest that you do that in some way if possible. um, Otherwise, anyway, we are actually showing you in this course, one or two systems I'll take, and we'll open up and see what all things are there inside. And then talk details about that. Okay, see, this just opening is not sufficient. We need to observe that carefully and make sure that we understand what learning that it has to offer from. Okay, say for example, this is one of the CD-ROM opened here. So you can see some of these systems here. So you have some motors which are driving some gears here, and then they are driving this slider which will slide along these rods here. Then there will be a motor on which the CD will be kept, and then the motor will be rotated, and then this will be sliding. So in this sliding, how people are making this slider. See, slider is there, so that means the friction will be there here. So how can no one can have a system with the friction, but we saw that okay, with friction you cannot position below 50 microns, for example. So how do you kind of position to nanometer range? Then what additional systems they'll have? So there are some systems which are very close to the lens, which are doing this positioning. So we'll see all the details in the classes to come. This is other kind of a system that you might be familiar with, as a child might have or as an adult. This is an interesting system both for childs and adults to play around with. Okay. Then we can have more details about these elements seen here. Okay, now so these are different elements of mechatronic system we are looking at, and we'll now get into little more details about the sensors. Okay, sensors you might have already studied. This is somewhat revision also, and there are some kind of things from the perspective of mechatronic systems also. Okay, so if you want, you may skip this part of the thing, or you may kind of brush through this. Is fine, no problem. what we are going to talk about is many different kinds of sensors, and how there is some relevance of that for the mechatronic systems, or their fundamental principle of operation. If you are kind of familiar with the sensor some fundamental principles of operation, the part of this somewhere utility into mechatronic system is a part which you might be needing to kind of look at. Okay, so sensor classification is basically based on output signal, type of the signal that is coming out of the sensor, and then based on the principle of operation. Okay, these are two kind of major classes that one can classify sensors into. Based on the output, you can have analog sensor or digital sensor. Okay, as the name suggests, the analog output will be like a continuous signal that is coming from the sensor, and digital signal will be like some number. After some time, some other number will come, it is in the form of a number or digital number, which is discrete kind of a number that will come. So analog, to read into microcontroller or digital domain, you need some kind of a conversion to be done, and so these digital numbers you need to have some way to read again, but there is no conversion that will happen. Okay, so these are the two domains of output that the sensor can have. We'll talk more about analog sensor, analog versus digital. What you will prefer? I mean, if you think simply what, based on whatever knowledge that you have so far, or some kind of a common sense, what you would prefer as a output type for the signal. Okay, some of the people who are more familiar with electronics and electrical, I mean, you are familiar with, you have taken some course in electronics also, but I don't know whether it is sufficient to kind of say this answer. So if you think the in the depth, if you see analog sensor on the oscilloscope, for example, okay, you'll see that typically analog sensor will have a lot of noise. Okay, this noise is coming from many different sources. There is ambient noise that is there. Now we are talking of this electronics noise actually. Okay, so this is any wire you keep it on, and start measuring something across the voltage across it, you'll see that this wire acts as an antenna, and wire keeps on kind of giving some noise as a signal. So in the electronics domain, if you see, people have to take care of this, lot of wires or lot of tracks that are laid on the PCB acting as antennas, and they are kind of putting in some kind of a noise into the system. Okay, so when that kind of a scenario is there, you have, it has a lot of repercussions on our mechatronic system design. So for example, you need to filter noise, or you need to do something about it if it is kind of coming in your way of getting the higher accuracy that you require for a given application. Okay, so from that perspective, you should look at the sensors which will have analog as an output. They are not generally preferred sensors in the system, or if they have to be used, then people will have a way to use it with a lot of filters and processing circuits, and that's kind of an additional cost maybe they'll have to incorporate, as compared to digital sensors, which will have just directly a digital output, and well, we just need to read it from the sensor, and that's it. It will be ready for use in the microcontroller. However, with digital, one will have a resolution issues. Okay, resolution may be a little poor than analog, depends upon how many digits you use to represent the signal. It depends upon really upon that. So one cannot generalize this statement, but analog, by theoretical kind of a means, analog sensors will have a infinite resolution. Okay, if you just talk about theory, not kind of consider these practical noise considerations, then analog sensors will have a infinite resolution, but it is not possible because of the noise that you get on the system. Based on the principle of operation, we can have another classification for sensors. You can have resistive, capacitive, inductive sensing, then optical sensing, or magnetic sensing, or piezoelectric kind of a sensing. So we'll just briefly look at these different kind of a classes of the sensors now. Okay, so yeah, so we have just seen this analog to digital discussion.